Hello everyone, welcome to one of the last videos of semester 1. Please make sure your information is in the top left and right hand corners of your page as we dive into 4-7 absolute value functions. So when we're dealing with absolute value functions, you have to understand that it is still a function where every input has exactly only one output. So let's go on. So the parent function of absolute value functions looks like this. F of x. Let's go make this. So f of x is equal to the absolute value of x. Now what does this look like? It's going to be V-shaped. That's what it looks like. Looks like this for the most part. Now, there are going to be some translations or dilations where we're going to stretch it or we're going to move it, slide it left, down, up, right. But for the most part, looks like a V. That's it. Is it going to be like a wide V, thin V? What's it going to look like? Just a V. Now, the domain will be all real numbers. Now, what does that mean? The domain means the x values. You can plug in all the x values you want increasing or all the x values you want decreasing. Doesn't matter. It's going to go forever left or right. Now the range, if it is the parent function, is going to be all, now this is just the parent function right now, all non-negative. So this is like the opposite. What's the opposite of negative? It's going to be what? All non-negative real numbers. Now, when I teach this, I like to graph a linear equation first and show you what it looks like. Where does this come from? So let's graph y equals 3x. All right, if we plugged in 0 for the x value, we would get 3 times 0 is 0. If we plugged in 1 for x, 1 times 3 is 3. So then we'll get 3. 1, 2, 3. If we plugged in 2, we would get 6. If we plugged in 3, we would get 9. Right there. Now if we plugged in negative numbers, so negative 1 would be negative 3. If we plugged in negative 2, we'd get negative 6. If we plugged negative 3, we'd get negative 9 right there. So this is our graph of y equals 3x. Looks like that. Now, what happens is we have this line right here. In the absolute value of y equals 3 times the absolute value of x, what we get is we get this graph, but everything's going to be positive. So anything below this line suddenly becomes above it and gets reflected above it. So if we plug in 0, 0 times 3 is 0. If we plugged in 1, 1 times the absolute value of 1 is 1 times 3 is 3. If we plugged in 2, we get the same result. 3, same result. Now, if we plugged in negative 1, make it, so this is what's happening. If we plugged in negative 1, it suddenly becomes 1 times 3. If we plugged in negative 2, it becomes 3 times 2 now. So we're going to get the same result, but now it's going to be positive. And the key part of this graph right here is that it's going to have a vertex, and it's going to have a line of symmetry right here. Let me do it in like blue right here. At the vertex point, let's draw it in blue right here. It looks like a mirror image left to right. So if you're trying to figure out, all right, where is this vertex? You can plug in some numbers, and you can eventually be like, okay, wait, it's in between these two numbers, has to be here. There you go. All right, let's go on. So We're going to take a pause right now. We're going to go to Desmos, so just give me a second. All right, we've now jumped to Desmos right here. So if I go through and I show you what happens, I like to show this and see, hey, this is what happens when you do some things to your equation. So for example, when you look, it says, hey, the absolute value of x plus 5. Well, watch what happens when we put plus 5. It moves up. Now if we do, hey, what if it's negative 6? Well, negative 6 moves down. It slides down. Now, reverting it back, it's like, all right, what happens when we minus 4? It's going to move left or right? Well, it moves right. So minus moves right. If it's minus minus, negative. So plus, so we say plus 9, let's say plus 9. It moves to the left. So plus 9. Oh, plus 9 moves to the right. That's the exact same thing as saying minus minus 9, because it's a double negative, which isn't good in English, but in math class, it's like, okay, minus minus is plus plus. Now, what happens if we decide to do 3? What happens? Well, it looks all of a sudden skinnier, but it's not getting skinnier, it's stretching up. So the x values are still remain the same, but now the y values are times 3. Well, what happens if it's negative? Let's say negative 2. Well, if it's negative, it flips over. Now, if it's times negative 2, it's going to stretch twice as far, but in the negative direction. Now, the final one that we see right here is, hey, what if it's a fraction, like 1 divided by 2? Well, if it's 1 divided by 2, it compresses. So we're going to jump back and show you. Now, if you want, you can play around with this on Desmos, but give me a second. All right, now we'll jump back. So looking at this, we understand that, hey, if we're saying this plus 5, that's going to move it up. So let's do our text box. So we're going to translate up 5 units. Oops. Now, if it's a minus or it has a negative, it's going to slide down or translate down. Slide down 6 units. It's going to go up negative 6. Well, that means go down 6. Now for this, the trick is, hey, I know it says minus. And we might think, oh, it's going to go to the left or right. Well, it's going to go right. So we could say, hey, slide right 4 units. Or translate. So if it's minus minus, it becomes a plus. This would be translate 9 units to the left. Now, translate and sliding are the exact same thing. They're the same action, just using different terminology. So now remember what happened when we had a multiplier. It's going to stretch the graph vertically. So the x values are the same, but now the y values are times 3 more. So like instead of being 1, 1, it's now 1, 3, because it's times 3. Not times 3 more. All right. Now the negative multiplier means it will reflect over the x-axis. It will go down. The v, instead of going up, will now go down. Reflect the absolute value function or graph. And it will also be twice, 2 times vertically stretched. Now, when it's a fraction, it's going to be compressed. The graph is compressed. It is half as tall now. So instead of being like 1, 1, 2, 2, 3, 3, 4, 4, it's now going to be 4, 2, half as tall now. All right, all else fails, if you're struggling, don't forget that you can just plug and chug. So when we plug and chug, all you have to do is you're like, all right, I know I'm supposed to do something with, there's a 2. So let me test out -2, let me test out 0, let me test out 2, and you know what? I'm going to test out 4 as well. So you just test out some numbers, see what makes sense. All right, if I plugged in 0, 0 minus 2 is -2, but it's in absolute value, so now it's positive, and then 2 minus 7 is -5. Oof. Now if I plugged in 2, 2 minus 2 is 0, minus 7 is -7. Let's plug in 4. 4 minus 2 is 2, 2 minus 7 is -5. Hey, wait a second here. We have repeats. When we have repeats, in between will be our vertex. Well, looks like our vertex is going to be that 2 right there. Well, let's plug in this. What happens here? We want to make sure. -2 minus 2 is -4, and 4 minus 7 is -3. That works. So let's plug it in. -2, -3. 0, -5. 2, -7. And then finally 4, -5. Well, there's our graph. And if we graph that, it should have symmetry at x equals 2 right there. Just understand that when you're drawing this, you have to make sure, hey, on your graphs, you have to make sure that it's going to continue forever. So looking at this, I know that the domain is going to be all real numbers. So let's write this out. The domain will be all the numbers left and right. So the domain will be all real numbers. But the range, it goes forever up. So it's going to be always increasing. But it has a minimum. The minimum will be at y is going to be greater than or equal to -7. Well, it's not either or, it's equal to. So it's going to be, hey, y is going to be, well, that's equal to. If I want to be precise, I'd probably say, hey, the range is greater than -7. All right, thanks guys. I hope you guys have a wonderful night. I'll catch you guys in class. Bye.